Today's lesson is on angles and their measures. And I've started out writing an essential question. Sometimes you might want to take your notes and then come back and write an essential question. So I'm going to try to remember to do that when I finish this lesson. If I don't remember, then you go ahead and do it on your own. Let's see what we're talking about, and then we'll make a good essential question when we get finished. Let's start with some terminology like we often do. What consists of two different rays that have the same initial point? Well, of course, that would be an angle. The rays in an angle would also be known as the sides of the angle. The initial point of an angle, I'm going to assume we're talking about the vertex of the angle. That would be the initial point of each of the rays that makes up the angle. Angles that have the same measure are congruent angles. And of course, remember, we can use the symbol for congruence like that. What are all points between the points that lie on each side of the angle? Well, let's look at an angle here. All the points that lie on each side would be all the points on each of these rays. The points that lie between those would be the interior. All those points are interior to the angle. All points not on the angle or on its interior, obviously, would be exterior points. An angle that measures 90 degrees, you've been knowing this for a very long time. That's a right angle as opposed to a wrong angle, I guess, or a left angle. An angle that measures between 0 and 90 is, of course, an acute angle. If the angle measures between 90 and 180, we know that it is an obtuse angle. An angle that measures exactly 180, we know is a straight angle. And if an angle measures more than 180, we call it a reflex angle. We won't really do anything with reflex angles in geometry, but you will need those a lot when you get to pre-calculus. Sorry, it's just an angle, a reflex angle. All right, so how do we measure angles? Consider point A on one side of ray OB. So there we go. The rays of the form OA matched 1 to 1 with real numbers from 0 to 180. The measure of angle AOB, and of course I could have called that BOA, that would be the same angle, is equal to the absolute value. It's kind of like we did with the segments. Absolute value of the difference between the real numbers for ray OA and OB. So for instance, I can see that this is, B is at 0. I'm just making this up here. And to try to give you an example, oh, this is very hard to see. 90, what does it go up by? Tens or fives? I can't even tell. Let's say this is 115, about 115 here. So I know that the measure of angle AOB is the absolute value of 115 minus 0, which is 115 degrees. All right, so there's just a little example for you. If P is in the interior of angle RST, here's angle RST. Okay, P is on the interior. We can see clearly that it is. Then what do we know? Well, we know that the measure of angle RSP plus the measure of angle PST has to equal the measure of the whole thing, which is angle RST. And you'll actually learn in just a little bit that this is known as the angle addition postulate. You will use this many, many times when you're developing proofs, so don't forget it. Take a moment here, get all caught up with your notes. Just take a second, make sure this all makes sense and sinks in. Let me make sure I didn't mess up with any of my letters. RSP plus PST equals the measure of RST, so we're good to go. So I imagine we've got a couple of examples here. Let's see what we have. Let's just start out by writing our angle addition postulate. So I know that the measure of angle BCY plus the measure of angle YCD equals the measure of angle BCD. All right, so what are we given here? We're given the measure of BCY, so I'm going to plug that in. Good old substitution property. 8x minus 2 plus the measure of angle YCD is 104. And the measure of angle BCD is 20x minus 6. So I'm asked to find the measure of angle BCD. Well, how are we going to do that? Of course, we're going to have to solve for x, and then we're going to plug that value for x right in there so we can find out what the measure of angle BCD is. So why don't we do this? Why don't we keep our numbers on the left and get our x's on the right? So we'll have 104 minus 2 plus 6 equals 20x minus 8x. So 102 plus 6 is 108. 20 minus 8 is 12x. And that tells me that x is going to be 9. So don't stop there. Don't say the answer is 9, because what I need to do is plug 9 in here and find the measure of angle, because the question is, what is the measure of angle BCD? It's 20 times 9 minus 6, which is 108 minus, sorry, that's not 108. 20 times 9 is 180. 180 minus 6, which is 174 degrees, and that looks about right. That looks like it's almost a straight angle. Measure of angle BCD is 174 degrees. All right, why don't you pause the video here and you work this one, come back, and check your answer. Let's start by writing the angle addition postulate. Measure of angle EDQ plus the measure of angle QDC equals the measure of angle EDC. Or I'll call it CDE, since that's what it's called in the problem. All right, let's substitute in what we know. The measure of CDE is 8x plus 9. I'm going to plug that in right here. Sorry, 19. 8x plus 19. The measure of angle CDQ, which I called QDC, but it's the same, is x plus 12. And the measure of angle QDE, which I named EDQ, but that's okay, is 84 degrees. So all we got to do is, just like we did above, solve for x, plug it in to find our angle measure. So we got 84 plus 12, that's 96, minus 19 is going to be 8x minus x. So 96, that's going to be 79. Nope, not 79. My arithmetic's not very good this morning. That'll be 77. 77 equals 7x. Therefore, that's a little symbol for therefore, x equals 11. All right, but they're not asking me for x. They're asking me what is the measure of angle CDQ. So CDQ, let me come right down here. I got to take up a little bit of my summary space. Measure of angle CDQ equals x plus 12, which is 11 plus 12, which is 23 degrees. Don't forget your units. Write yourself a nice summary, and there you have it.